everyone, we're going to find the limit using L'Hopital's rule of as x approaches 0 of cosine of x to the power of 1 divided by x squared. All right, since we have this power thing going on, let's take the log, see what goes on here. If I take the log of cosine of x to the power of 1 divided by x squared, I can use my power rule and move this in front here. So I'm going to have 1 divided by x squared times log of cosine of x. And then we can use L'Hopital's rule to finish this up. So we want to look at the limit as x approaches infinity of the log now. So I'm changing it up a bit. We'll fix it later. Cosine of x to the power of 1 divided by x squared, which is going to equal the limit as x approaches 0. What did I put infinity? 0. And then I'm going to write this down. So this is going to be log of cosine of x divided by x squared. If you apply the limit now, you're just going to get the form of 0 divided by 0. So that means I can differentiate. Since it has this form, I can use L'Hopital's rule and differentiate the numerator and the denominator. So when you differentiate the numerator, what we're going to do is write this as h here. So you're going to write h for the limit, and the limit as x approaches 0. So when you take the derivative of the numerator, that's going to be 1 divided by cosine of x times the derivative of cosine of x, which is negative sine of x. So I'm going to put that right here, negative sine of x. And this is all divided by 2x. Now I'm going to simplify this and write this as the limit. I'm not putting the h, so that means I'm not differentiating. I'm just going to move these two together. Because derivative of x squared was 2x, so we have negative sine of x divided by 2x cosine of x. Now looking at this, right here, this is tan of x. So let's simplify some more and write this as the limit as x approaches 0 of negative tan of x divided by 2x. We still have the form 0, 0. So I'm going to apply L'Hopital's rule again. So keep this one in mind. We have negative tan of x divided by 2x. So when you apply L'Hopital's rule again, get the limit as x approaches 0, and I'm applying the rule, and we had negative tan of x, so the derivative of negative tan of x is negative secant squared of x. And in the denominator we had 2x, derivative of 2x is 2. Alright, since you apply the 0, secant squared of 0 is going to be 1. So you have negative 1 divided by 2. Now that's the limit with log. Alright, since that's the limit with the part with log, we have the log of the limit as x approaches 0 of cosine of x to the power of 1 divided by x squared. That equals the limit of the log, I'm just switching these two around, of cosine of x to the power of 1 divided by x squared, which equals negative 1/2. So to get rid of the log here, we're going to write this as equals, where's the x approaches 0. All right, since I have that, I can write this as the limit as x approaches 0 of cosine, I'm getting rid of the log, because I want to get back to my original problem. Cosine of x to the power of 1 divided by x squared. And now write this as equal to e to the power of negative 1/2. So I'm just using my properties of logs and exponents. And this can be written as equaling, I'll put it up here, 1 divided by square root of e. Or you can just keep it as e to the power of negative 1/2. But this is your limit. Thank you. Have a nice day. Bye-bye.